Miss Collier explains.
Expressions and equations.
Unfortunately, that's not all we need to learn about for our introduction to algebra. There are some more things and some more terminology we need to know. So for this part of the lesson, we have new learning intentions. We want to understand the difference between an expression and an equation. And again, we want to be able to write an equation from a word description. We will know we have been successful this time when we can identify equations and we can write equations from word descriptions. Now that we've finished with the terminology of algebra, there is one more thing we really need to understand, and that's the difference between an expression and an equation. Now, an expression is a collection of pronumerals, numbers, and operators, but it doesn't have an equal sign. So for example, 2x plus 3. We've got this, it's sort of like a little formula, but we have no idea what it equals. On the flip side, an equation is a statement that says that two expressions are equal to each other. For instance, 2x plus 3 equals 4y take 2. This equal sign makes it an equation. We can see the word, part of the word equal in that word. And that equal sign tells us that these two expressions equal each other. They represent the same value. So that's the difference between an expression and an equation. An equation has an equal sign, an expression does not. Because an equation has an equal sign, that means all equations have a left-hand side and a right-hand side. Here's my left-hand side, here's my right-hand side, and all equations have to have an equal sign. We use the word LHS to represent the left-hand side and RHS to represent the right-hand side. This will come in handy later on. I also want to bring up a big point that kind of seems a bit obvious, but sometimes people forget. The equal sign means that those two things are equal to each other. So we can't write one thing on the other side if it's not actually equal to each other. And that becomes really important later on when somehow people just seem to lose numbers or lose letters and they make their equations not equal anymore. The whole time we're working, we need to make sure our equal sign actually shows two equal things. All right, this is a great little diagram to show you how all of these big words that we've been using actually are viewed in an equation. So this whole thing here is an equation because it's got an equal sign. But it's made up of two expressions, 1, 2, and it's made up of three terms, 1, 2, 3. This term here has a variable or a pronumeral, and therefore it also has a coefficient. And these two terms are constants. So you can see how we can break up this equation into the parts that we've learnt today. Here is a ginormous equation, and you will not be working with ones this big. But for today, I just want us to use this giant equation to identify the things that we've learnt. So first of all, tell me, is this an equation or an expression? I hope you said equation because I said equation 3 times, so you should know by now. But the other reason you should know is because it's got an equal sign. So we know it's an equation. Now we can identify the coefficient of xy. If I look for xy, the coefficient is 3. Notice xy is different from x. I can list all the variables. So the variables are x, y, and z. These two x's, they represent the same number. So if it's the same letter, it means it's going to be the same number. The reason it's different though is that this x is being times by y. We can identify any constants. I see a 5 and I see a 16. And we can see all the terms. Here's 1 term, 2 terms, 3 terms, 4, 5. So you can see we can take this equation, we can break it up into its parts. As I said, algebra is used in so many ways in life, but just one example is the need for mathematical equations to build and launch rockets into space. Okay, our first set of questions are pretty easy. All we have to do is identify whether something is an expression or an equation. Okay, 3 plus 5 equals 8. That's an equation. It has an equal sign. 7 plus 7 equals 18. It's an equation because there's an equal sign, but it's mathematically incorrect. But it's still an equation because it's got an equal sign. 2 plus 12, that's an expression, not an equation. 4 equals 12 take x. Equal sign, equation. 3 plus u, expression. You give it a go. Let's check them real quick. No equal sign, equals, equals, nope, equals. Easy. Okay, I hope that 7 plus 7 equals 18 was killing some of you like it was killing me, but it's okay. Our next activity is to classify whether or not an equation is true or false. Some people have gone ahead and they've made equations that are not actually equal to each other and they've used those equal signs wrong. We need to identify which ones they are. 7 plus 5 equals 12. That is correct. True. 5 plus 3 equals 2 times 4. So we're going to do a little bit of math here. 5 plus 3 equals 8, and 2 times 4 equals 8. So they are equal to each other. True. C. 12 times 2 take 1, brackets, got to do that first. So 12 times 2 take 1 is 1. All right. And 12 times 1 equals 12. 14 plus 5 equals 19. False. You try some. Okay, let's quickly check these answers. 4 plus 9, that's 13, so that is false. 12 take 3 equals 9, and 5 plus 4 equals 9, so that is true. 9 equals 9. And we have some brackets. 3 plus 2 equals 5, and 4 times 5 equals 20, and 10 plus 10 equals 20. So that's true. Okay, so now you can write expressions from descriptions, so we quickly need to do equations. They're much the same, it's just we know they're going to have an equal sign this time. The sum of x and 5 is 22. So sum is plus, so x plus 5, and is another word for equals. So x plus 5 equals 22. Equation. The number of cards in a deck is x. In 7 decks, there are 91. So if I've got cards and I've got 7 of them, that means multiply. So I've got 7x, and in all of them, there's 91. So the total, the equals, is 91. Now, quickly note, lots of people will be like, we need to figure out how many cards are in the deck. No, that's not what it's asked you to do. Okay, they've just asked you to write an equation. So make sure you're checking and not doing extra work that you don't need to do. C. Priya's age is currently J. In 5 years' time, her age will be 17. 5 years' time, that's plus 5. So J plus 5, and in 5 years, it'll be 17. So it's equals 17. And D. Corey earns W per year. He spends 1/12 of it on sport and 2/13 of it on food. The total amount Corey spends on sport and food is 15. This is a very complicated one, but what we can do is we can do 1/12 of W plus 2/13 of W equals 15,000. So we can see that 1/12 of W is for the sport, 2/13 of it is for the food, and the total of that, so adding it all together, equals the 15,000 he spends, which is a lot on food and sport. You try write some. Let's quickly check your answers. Product means times. So the product of 3 and A, so that's 3A is 21. 3A equals 21. B, the sum of P and Q is 10. P plus Q equals 10. C, Tristan's age is currently T. 3 years ago, he was 24. So his age is T, and we're taking away 3 years because it's 3 years ago, and that was when he was 24. Lastly, D. John has A marbles and Michael has B marbles. When John combines half of his marbles with 1/4 of Michael's marbles, they have 120. This is tough again, but let's think about it logically. John has half of his marbles. So half of A. Half times A. Combine means plus 1/4 of Michael, so 1/4 of B equals, when they add those two together, they have 150. Done. Now, I know a lot of this can seem very complicated, but we just have to stop, think logically, take it step by step. What are they asking me to do, and how can I represent that using letters and numbers? Another big hint that I have for you is to go and revise different words for addition, subtraction, multiplication, and division, and even equals. There's lots of different words that people use: sum, product, quotient. We need to know what each of these mean in terms of our operations. If you're not sure about that, it's time to study up on it. I know we covered a lot today, but I'm hoping you feel a bit more confident about identifying coefficients, variables, pronumerals, terms, and understanding the difference between an expression and an equation. I hope that you can also read a word description and know how to put that into a mathematical sentence that is either an expression or an equation.